Is it too late to start a career in DevOps? And is there a market demand for DevOps engineers? So what is DevOps? What is cloud native? What is site reliability engineering? And what is DevSecOps? What is infrastructure as code? What is Agile? What's SDLC? What's waterfall? All of these are questions that are going to be answered in this video. So stay tuned and let's rock and roll. What is DevOps? Why do we use it? What are the tools? What's the benefit? Before we understand what DevOps is, let's understand what the software development lifecycle is. Okay? And that is nothing more than the framework that developers and companies producing software or enterprises are using to create software applications. And usually this number of steps in the framework, they could be planning, we want to make an application to do such and such. Then setting up the teams and starting to build the code. And then building the application from the code, and then testing to make sure that it does what it's supposed to do. Then releasing the software or the version number, and then deploying it, and then operating that to enhance it and optimize it, which goes again through planning to enhance, and then coding, and then the same thing again and again. These steps will help us in dividing the entire software development process into tasks that can be assigned, completed, and measured. So basically, throughout the project, you can manage it and you can make sure whether it's going on track or it's behind. If there are bugs and software problems or issues, and you do testing and you provide feedback until it is ready. So that's a framework, an architecture, roadmap that we have to follow in order to get from the idea until there is a product. Okay? And why do we use a framework like that? It will provide us a measurable way of providing or developing these softwares, and measuring also whether we are efficient or not efficient, and we can improve on that. It also will provide us an accurate analysis for every step. And also it will facilitate faster software delivery, as opposed to just working randomly without anything to govern or manage the entire project. And also that will ensure better quality for the software and better user experience at the end, because the software is meeting the expectations. So as we mentioned, the software development goes through these steps that we have talked about. And most important is we do frequent testing and we provide feedback to the developers so they can reiterate until we have a perfect software, hopefully a perfect one, not all the time. And then releasing and deployment. Okay, so we need to minimize the human factor, because if there's a lot of manual stuff happening, then we might have a lot of errors. We are human, and human beings make mistakes, right? So we would like to automate that process, and DevOps is all about this automation, bringing the operation closer to the development in order to ensure that they are working hand in hand and they can find out any issues as they arise, fix them, and move on. This is as opposed to having the developer work on everything and then they say, okay, we finished the code. Now it is for the testing team that we have nothing to do with the testing team. And then it goes to the operation and we have nothing to do after that with the operation. So instead of pointing fingers, work hand in hand as a team to ensure that we get to the deployment and operation and optimization without any issues. Okay, so the older way was we have walls between the different teams, and the new way is, no, we need to work collaboratively and we need to work in an iterative process in order to make sure that we reach our targets very fast with high quality, less errors, and also to make sure that they work hand in hand instead of pointing fingers at one another. Okay, there are many ways or distinctive methodologies that are used for developing software or managing software projects. And one of them was the old one, the waterfall and agile. And if you compare them side by side, we'll find that the waterfall used to have an analysis phase where all the requirements are gathered, and then they start planning, designing, building, testing, and deploying. The problem with the waterfall is it's once it kicks off and starts, it doesn't stop. It doesn't take new input, and it must finish the milestone before getting into any requirements gathering again. The agile method, it's all about an iterative process, a continuous process where we do everything again and again. So if we look at the waterfall, we are gathering requirements and designing, then coding, testing, deploying. But in agile, it says it doesn't work that way, because that means we may have a lot of surprises when we do testing, because we have been coding for a long time without integrating the code from the different development teams. So why don't we code a little bit and then test that, bring the code from the different teams. Let's say they finished one milestone. Then after that milestone, we bring in the code, we test, and we find out, okay, the expectation after this milestone, we should not have this or that problems. And we found out that we actually don't have them. So, okay, let's go ahead. So we integrate, test, code again, and then test, get feedback, and then code again and test, and so on until we deploy. So it's an iterative process where we repeat all the tasks again and again as we move on. Imagine that this is a tire or a wheel that is revolving, but also moving forward towards the goal of finishing the product. Okay, so the iterative nature of Agile made it much more popular than the waterfall. The waterfall is when something happens, it doesn't repeat. So the water comes from the falls, it goes down, then it hits probably some rocks, and then it moves horizontally, then it falls down, and so on. Okay, waterfall, as we mentioned, is a sequential methodology, and it is not the preferred one. So what's the DevOps? DevOps is all about, as we mentioned, bringing the teams, the operation and development together, and having them work hand in hand through the SDLC, through the software development lifecycle, to ensure we have a better product faster with less errors and achieve the highest user experience or the highest user satisfaction. Okay, now one might think, okay, so DevOps and Agile, why are you comparing the two? And we say that the DevOps, because it's automated, it allows us even to do more and more of these cycles, the code test. But not only that, but also we do code test and deploy. Then we need another feature, or users are complaining about something. And then we do again, coding, testing, and release. So we do more releases, and it could be multiple times a day. And now we have everything startups on web apps. So these apps, you will find a lot of updates. It's asking you, okay, updates are ready. Okay, install. Same thing happens, for example, with Android or with iPhone. You find a message that says, okay, update is available. Install, or maybe later on. And it depends on how it is critical. So that's what we need, and that's what the software application companies need. They need to be able to take the feedback from the customers, enhance and optimize, and provide a better user experience, and hopefully we can achieve that multiple times a day. So Agile and DevOps are different things, although DevOps does use the iterative process, but it does do a lot of deployments and a lot of releases as well. So when we use DevOps, we can achieve a lot more than if we just do Agile without the DevOps, okay? So please keep this in mind, because you might be asked the questions. We are already using Agile. Why should we move into a DevOps? Let's now get to understand some of the important CICD concepts that we will come across. Before doing that, let's reiterate or recap what we said about what happened before CICD. So before CICD, developers and the operation team, they used to work in isolation from one another, and also developers used to work for extended periods of time working on their code without any integration with the other teams or the other developers. And they used to integrate or merge the code less frequently. They did less testing, which means they also discovered integration issues that were more complex and took longer to fix, because of the fact that they did a lot of code before they started integrating with one another. So CICD, what is that? CICD stands for continuous integration, continuous deployment, and continuous delivery. So the CD is continuous delivery or deployment. The CI is the integration part. These are software development practices or best practices that are aimed at automating the process of, or the software development lifecycle of the software products. So we need to improve the software quality, and we need to integrate more so we can speed up the testing and discovering bugs and fixes that are early in the process so they can be fixed quickly. And that means we can do more deployments and more releases at a high quality, thus enhancing the overall software development lifecycle. If we think about continuous integration to start, So this is a DevOps software development practice. What does it aim at? It aims at integrating or merging the code more frequently from the different development teams or the developers in a shared repository, and then we build the application, or we build that part of the application by integrating that code and then doing testing to discover bugs and then provide feedback to the developers. So that means developers need to push their code more frequently into that shared repository, and then gets merged with the main code, and hopefully without any issues or anything. Then we start the validation and code testing. So the first thing is they commit code changes to a repository, let's say GitHub, for example. And then the CI tools, that part, or the tools that run the CI part, are going to start building and then testing. So the CICD pipeline is basically taking from the time that the developers start committing their code into a repository, and then merging the code, building, testing, and then hopefully if that cycle goes and then some iterations happen and then we have a clean code, then we go into the deployment or the release. So these two, or the CI and the CD part, is what we call the pipeline, or the CI/CD pipeline. On the other hand, continuous delivery and continuous deployment. What's the difference between the two? The main difference between the two is in, do we release only and then wait for approval or wait for the proper time to come and then deploy that release? And that is continuous delivery. If there is human intervention or human interaction to either trigger the delivery part, the provisioning part, the actual deployment, or to pre-approve it before it goes into production, then that's continuous delivery. But if we get from the CI and then there's a continuous deployment, which means the software is ready now and then it goes automatically to be deployed without any human intervention, so that becomes continuous deployment. Okay, so the CI has done the building, the merging, building, and testing, and now everything is clear. We went through the iterations and everything is okay. Now we get into the staging deployment phase or step in the pipeline. And then if it is continuous delivery, that means we go through manual intervention or manual trigger in order to deploy, or we go with the continuous deployment where the changes that pass all the CI and gets into the staging is going to be automatically deployed without any manual intervention. Let's now look at the most common CI/CD tools. We have Circle CI, Bamboo, we have Travis CI, and then we have GitLab, we have Buddy, we have Argo CD, we have GitHub Actions, we have Jenkins. A lot of famous and known and commonly used tools, but when you get into an enterprise or into a company, you will find either one or two tools at most that are being used. So do you need to learn all of these? And the answer is no. You don't need to learn all of these. You need to learn what you are going to use. The concepts are the same, but it's only about getting adapted to a tool, and there could be some subtle differences between this and that. So suit yourself, find the one that matches what you need, learn it, master it, and you can keep going. And you can from time to time kind of play with the other ones or read about them, use them to find out in test and development environments whether they are better or they will add to what you are doing, or maybe they are easier to use. And of course, if we look at the actual landscape of DevOps tools, and you'll find hundreds and hundreds of tools, and you don't need to learn all of these. You need version control. You need to cover the CI with the products that matches what you are doing. And then you need to cover the CD also in the pipeline with the tools that matches what you are looking for. And that's it. Nobody knows all of these. And of course, if you change from one job to another, maybe you learn more tools, and this is how you learn many of these tools. But I don't think there is anyone on the planet that have used all of these. And if there is one, then he must have spent, I don't know, 10, 15 years jumping between a contract to another contract to another contract to another contract in order to use all of these. And I don't think anyone would have mastered them all. Okay, again, the DevOps tools ecosystem. And what you need to do, as we mentioned, when it comes to deployment, you need to learn one. When it comes to visualization and containerization, you need to know Docker and Kubernetes at least. And then when it comes to reports and all that, you need also to find out a tool that will help you with that. Test automation. And then when it comes to static code analysis tools, build tools, CICD tools, scripting tools, so Python, Bash, Perl are examples of that. All right, so you don't need to know everything, but you need to know one that will help you with scripting, one that will help you with CI/CD, one would help you with the build, one would help you with the monitoring, one would help you with the containerization and visualization, and you should be good to go. And the job also may dictate what tools you need to learn. So you don't have to go and find out this or that. But definitely you need to master one of each in order to be able to at least understand the concept, have a way to deploy it, to do some projects before you start your DevOps career. Cloud native applications, cloud native infrastructure, cloud native service, cloud native this and that. What is that? What is meant by cloud native? And there are two definitions, the CNCF, the Cloud Native Computing Foundation, and also from VMware. So cloud native in CNCF, they say that these are cloud native technologies empower organizations to build and run scalable applications in public, private, and hybrid clouds. So these cloud native technologies, they will help you successfully deploy your stuff on the cloud, basically. Okay, so what are these technologies or these features? If you are using containers, if you are using service mesh, microservices, if you are using immutable infrastructures, declarative application programming interface APIs, these are some of the technologies that if you are using, you could be labeled as a cloud native implementation. Okay, VMware defines it in a little bit different way. Cloud native is the approach to building and running applications that exploit the advantages of cloud computing delivery model. And if you think about it, it's more or less the same thing. And then they speak about the same thing. You are using public, private, or hybrid clouds, and how your applications are created, deployed, not where. Okay, so that's slightly different, but still talks about the cloud again. And if you are using DevOps, if you're using continuous delivery, microservices and containers and the monitoring tools and delivery tools, you should be cloud native. So it's more of, are you using the technologies that have emerged with cloud? And if that is the case, then you are cloud native. Now, when we talk about cloud native applications, that means we are talking about independent services that are packaged as lightweight containers. So you must have containers, you must have Kubernetes, which is the best tool to run that, or maybe OpenShift. And they are often delivered in DevOps pipelines that includes CI and CD. Then we have another buzzword, which is DevSecOps. So DevOps, we said it's the marriage between development, IT operation, and application delivery. So the intersection between the three is what the DevOps are. And guess what? Add to that the security of the pipeline, the security of the application, and it becomes, the intersection becomes the DevSecOps. And then we have the infrastructure as code, a very important component in the DevOps, and that is defining or describing your infrastructure as a script, as a code that is written, and it can be deployed into cloud computing environments or different, or even on premises. So infrastructure as code means that you manage your IT infrastructure using configuration files or the description or the scripting files. Okay, and IAC, sometimes it's called infrastructure as code IAC or infrastructure as a code. So either this or that, it's IAC or IAAC. That's the process of managing and provisioning computer data centers. So the entire data center can be defined into configuration files that can be used, as opposed to using physical hardware configuration. So someone gets dispatched to start configuring and deploying and all that, or even interactive configuration tools like the AWS Management Console or portals and all that. So that's what infrastructure as code is, and that's very important. And Terraform is the most famous one or the most common one, and it's vendor agnostic. So it can work on AWS, on Azure, on Google, on Alibaba, on IBM, or even on premises as well. So if we look here, what the developer or the scripter, I would say, or even the ops person, he will write the code. So he writes the script and which describes the infrastructure. And that then gets pushed into the infrastructure where it gets deployed. So it might be a cloud or on-prem infrastructure, and both of them would work, and then you get management, you get responses. It got deployed right. There were problems, there were errors and all that, and you troubleshoot, fix your code, and then you go ahead. And of course, that code with versioning control like Git and GitHub, it can even manage the different versions of the configuration files using these tools. SRE, or Site Reliability Engineer. And how is that different from a DevOps engineer? Of course, we are not going to dive deep, but at least you need to understand why would you want to become an SRE as opposed to a DevOps engineer, or why would you want to be a DevOps engineer and then move into an SRE? So why do we need the SREs, or why do we need site reliability or reliability engineers, basically? There is one thing that is a fact. In software development, developers are keen on finishing and pushing their code quickly, so doing more frequent releases. While the operations team, they always are keen on the stability of the system more than deploying every time there is a new release, just go ahead and deploy it. And DevOps focuses more on the first side, on the speed and stability of releases, but not on the operation side and monitoring what happens into operation. It could be that DevOps thinks that this is 100% clean. When it gets deployed, then we have problems. So DevOps does not define who takes care after the deployment. And that's where the SRE comes into play. So the SRE is a practice, or site reliability engineering is a practice where the software tools are used to automate the operational side and the application monitoring. And this is how we can ensure it's not only that we have made or optimized the CICD pipeline, but also beyond that, we can look at the monitoring, we can find issues, and then we can give feedback in order to enhance the process. So you can look at the site reliability engineer as someone who can probably be engaged in DevOps, but also engaged in the monitoring part and ensuring that whatever is deployed is even enhanced more than the DevOps. Now, depending on the organization, they could be completely different teams, or they could be integrated teams, or maybe the senior people or the lead engineers, they will be entitled to look into the monitoring and the well-being of the releases after they have been deployed, not only throughout the DevOps process. So just to quickly recap, the DevOps is more of a culture than a set of tools. It's agreeing that we need to automate. We need to enhance the process. We need to improve the software development lifecycle. We need to be able to release more frequently, but also more accurately with less issues and problems in the software. So it's not just the tools, but it's the whole concept or the whole culture that needs to be adopted in order to look at this part of the automation and then site reliability engineering as integral components of the success of the practice or the company or the enterprise or the different teams within. So a question that you may have: are you too late to start a career in DevOps or in DevSecOps or in site reliability engineering? Is it too late to learn cloud? And the answer is absolutely not. You are in the perfect time. Shortage of skills is increasing and more skills are in demand compared to what's available. So if you look at what the analysts are forecasting, you'll find that the global cloud computing market is going to triple by 2030 at a very high growth rate, annual growth rate, to $1.5 trillion. $1.5 trillion. So this could be the revenue of so many companies combined. And I'm talking about huge companies combined in order to make that number. If we look at another view, spending on public cloud services, and this is by IDC, you will find that they are anticipating that by 2027, so 3 years from now, it's going to be $1.35 trillion and at a growth rate close to 20% or 19.9% annually. That's a lot of money. And if you'd like to find out what is contributing to this growth, it's going to be the use of edge services, artificial intelligence, machine learning. That's what all the startups are running on the cloud. And which cloud providers you should invest in knowing and learning? These are the big three. So AWS, highest market share. This is in Q2 2022. This is in Q2 2023. So that's 1 year. the market share of AWS has declined. There is a 2% lost, and you'll find that the 2% are lost 1% to Microsoft and 1% to Google. Google market share is going to increase, and I'm recommending learning Google right now because the AI and machine learning on Google, given the fact that they have developed a lot of the algorithms and all that, it's going to increase with time. I'm noticing that in the US, and it will come to your area wherever you are very soon. So what about DevOps growth? What is the expectation? You'll find that for the market value in 2022, it was about 8 billion. It's expected in 2032 to increase by 9 folds to 70 billion. And the growth rate is going to be about 20%. And why is that? This is because the adoption is increasing. People are realizing, and companies are realizing that automation is beneficial. Software houses, even clients, end clients are realizing that automating things will enhance the releases, will enhance the quality, and so on, will save costs as well. And that is why the adoption is going crazy, and that's why it's going to increase by that. If you are in North America, the market in 2032 is going to be about 25 billion. So more than 1/3 of the global DevOps market at that time. And if we are looking at the solution segments, the vendors and tools and so on, now it's more than 5 billion, but it's going to grow by 2032 to 45 billion or more than that. Salaries. Now you are going to invest, you are going to build a new career. Is it worth, from a financial perspective, the effort and time I'm going to put into this? And the answer is absolutely yes. The average cloud DevOps engineer, the one who can do DevOps on the cloud. DevOps does not have to be only on the cloud, it can be on premises as well. But someone who combines these two skills on average, and here we're talking about a cloud engineer, I'm not talking about a senior one. We're talking about close to 140,000 US, and the upper margin is 171, or the upper cap is 171,000 per year. I have seen 220, 230, 240, 250. So if you start in this career in the span of 2-3 years, you're going to be senior and you're going to be commanding that kind of packages. In the UK, 60,000 pounds per annum, and I'm expecting that this is less than the actual number. It goes up all the way to the 80s. Australia, it goes up close to 180,000, and the median is at 140. India, you have a huge income as well potential that is going to be there, between 1.35 million annually. That's the average, and it can go up to 2.5 million rupees. And in UAE, representing the Gulf countries, it's still a high income that is being paid. And in Germany, it can go up all the way to 80-something thousand euros. And I have heard firsthand that if you have this and you are certified in the cloud and infrastructure code and you have some experience, that you can go up to 120,000 euros. So there is no excuse. The demand is going to be increasing, and the market size is going to be increasing. The revenues are going to be increasing, and the salaries are going to be increasing as well than these figures, because wherever there is shortage, there will always be a competition between the employers to hire the available skills. So perfect time, and all of these salaries and salary figures are from talent.com. So you can go ahead and verify that yourself. What about the DevSecOps market? Same thing. It's currently, or in 2022, it was about 4.4. Now it's about 6 in 2024, early 2024, about 6 billion, but it's going to increase by 22% to 30 billion by 2032, at a 22% increase. Because now you are doing DevOps, you're doing cloud, you're doing all of that. Where is the security aspect? I mean, if you are doing things publicly, if you are pushing code into repositories and all that, there has to be security around it. There has to be scanning for the code to make sure that everything is okay. You don't have to code it, but you are going to be doing the security part and the ops part into that. And if you take it to the monitoring part, then you will be doing site reliability engineering and security as well. All right, so it's well worth it. You are not late, you are in the perfect time, but you need to start right now. Have a look at what we have, the offerings in DevOps and DevSecOps and cloud and IT and Linux and all that we have on www.dolphin8.com, maybe you will find what you are looking for. I hope you liked the video. I hope it was beneficial, and now you understand why you should go full speed ahead in pursuing a career in DevOps or in DevSecOps or both together, and also having infrastructure as code skills. If you like the video, please support us with a like, subscribe to the channel to receive notification about new videos, and also share with others so everyone will benefit from that. Thank you so much for watching, and I'll meet you again in the next video.